Hello, hello. Okay, so we're gonna go ahead and do now the these next two worksheets. We're gonna finish this one from day 3, and then we're gonna go ahead and just wrap this one up from today, day 4. So this one, it says match each function to its derivative. So we have a bunch of inverse functions. So make sure that on the side here, I didn't even do it, so I'm gonna do it right now. You have your derivatives handy. Let's start off with the first one. So we have sine inverse of 2x squared. So, in technicality, I see with this is that there's only two things with a square root. So, if there's only two things with the square root, and that leads me to believe that only one of these two could be our sine inverse. So let's go ahead and simply just do its derivative. So we have first 3 times 2x squared prime over square root of 1 minus 2x squared squared. So that's going to be 4x squared. So if that's going to be 4x squared, then the only one with 4x squared on it is going to be this guy. And that would be your answer. And you can see that also because we'll have this, which will be 4x times 3, so that will be 12. So that does check out. All right, keeping up the idea with the square roots, I'm going to go ahead and use this guy. And this guy is 2 times negative 3x squared prime over the square root of 1 minus 3x squared squared. And that one's definitely going to be this as well for similar reasonings. Okey-doke. So now we have tangents. Now tangents are tricky because they have the same bottoms. It's plus the inside squared, but these also have plus two different squares. So let's just go ahead and do it a little bit. We got 5 times 3x prime over 1 plus parentheses 3x squared. That's going to be 9x squared. So that's probably going to be this guy over here. We see that there's no x on top, but 3x prime, the x would disappear. And 5 times 3 is 15. So cross elimination, we know it's that one, but let's just do it a little bit. We have 2 times 1 plus 2x squared squared. And then over 2x squared prime. We see here that the x still prevails, and this would be 4x times 2, so that's 8. That would become 4x to the power of 4, so for sure, that's the answer for that one. All right, now that's it. Let's go ahead and move on to our last worksheet for Unit 2. So this is implicit differentiation parts. So it's given this expression, find dy at 3 comma 4. So this is a little trickier in that now we have a specific x and y to worry about. So first we need to solve for dy dx or just y prime. Um, let's see. I'm gonna go ahead and use my prime. No, I'll use the dx dy notation on there, or dy dx notation. Okay. So the left side, d over dx is equal to d over dx of 9. That comes out to 0. This comes out to, well, we have to split up first, technically. And that just becomes 2x, and then that becomes 2y d dxy. And then we could do some rewriting, and we would get dx plus 2y dy over dx is equal to 0. Subtract the 2x and divide by 2y. dy over dx is equal to negative 2x over 2y, which simplifies to negative x over y. But now we have the added difficulty of plugging in a specific x and y. However, this isn't really difficult at all. We see here that if we just plug those in, we get negative and then 3 over 4. All right, hopefully that's straightforward. Let's keep moving. Here we can see that d of dy of xy is equal to d of dy of 12. That's going to be a glorified product rule, which if you watch this video right after the lecture, we have this done already. So I'm just going to go ahead and copy it. We have y plus x dy over dx is equal to 0. And then we just dy over dx is equal to negative y over x. And this time, if we plug in values, we technically at first get negative 4 over 2, which we know is just negative 2. Next one. Given x cubed plus xy is equal to 6, find dy dx at 2 comma 1. Okay, again, not that difficult. Dx, I'm going to skip some steps. Plus dx of xy, d of dx of 6. We know this one, we don't, we know this one, 3x squared, plus parentheses, y plus xy prime, and then it's equal to 0. Now, there's no product that happened inside these parentheses, so we can just, outside these parentheses, so we can just write it plainly like this, subtract those values that aren't y prime, and then divide by x. Now, the step wasn't to differentiate this expression, it was to find that differentiation at 2 comma 1. So now I'm going to plug in x to be 2 and y to be 1. So I have negative parentheses 3 times 2 squared plus 1 over 2. So that's going to be 12 plus 1 over 2. So negative 13 over 2. All right. Last, let's do the derivatives of each of these guys. Make sure you also have your notes out for this one because we just learned the log derivatives just now. Okay. So I have mine out. So hopefully you guys have yours out too. Let's go. We first note that for exponentials, we just basically rewrite that function and then multiply it by its powers derivative, which we know is just 10x minus 3. Then for here, same thing, e square root of x squared plus 1. And this is trickier because we multiply by this derivative, which we can't technically do. We have 1/2, 1 over the square root of x squared plus 1. and then multiply this by its derivative, which is just 2x plus 0, right? But we don't have to worry about the 0. From here, we could definitely do some simplification. We'll have those 2 and that half cancel out. And then we're left with just e square root of x squared plus 1 times x over the square root of x squared plus 1. Okie doke here. So that gets thrown on the bottom. 1 over sine of 3x times the derivative of sine of 3x, which is cosine of 3x. There's something inside, so we have to multiply it by that's derivative, which is just 3. So your answer can be simplified to 3 times cotangent of 3x. Doke. Alright. Let's keep it moving. That gets first we want to simplify that because that power is going to get very annoying. And we do that 2 times 1 over x squared plus 3, and then times it by that derivative is just 2x. So we're left with 4x over x squared plus 3. Okay. We got a product rule situation. So that's going to be 2x first times that expression plus x squared times this guy's derivative, which is x3 times now derivative of what's inside it, so 3x squared. Okay, so that definitely gets some simplification. We can factor the 3x squared, and we're left with 2x, combine this guy, plus 3x to the power of 4. This is the answer, but you could just do a step further. You could take out an x. There's not really too much of a point to that. Here, but I'm gonna box it. In the case of you get asked on your homework, give me the most like simplified answer, right? Okay, over here we have another product rule, so it's going to be 1 times ln of x plus um x times 1 over x. It's just going to be 1. So this is equal to ln of x plus 1. Over here, we have this guy's derivative first, and then derivative of what's inside, which is just cosine of 4x, and derivative of what's inside of that, which is just 4. And that's kind of basically it. You can't really simplify that much more. Over here, same thing I'm going to do. I'm going to sneak out the power. And we have that this is 1/2 of 1 over x squared plus 1, and then multiply by this guy's derivative is just 2x. And this becomes x over x squared plus 1. Alright, so after this, and after you do the homework, hopefully you guys are derivative masters, and we can go ahead and try to secure this skill as much as possible, because these derivative skills will play the largest part in your future mathematics classes or any other classes that contain advanced math. Alright, see you all in the next video, and good luck on your test. Bye-bye.